My name is Steve Geisel. I'm the Regional Sales Manager for the LAKOS Industrial Division. I currently cover the eastern half of the United States and Canada. And I want to take this moment to thank everybody for taking time out of their schedule to join us on our webinar today, where we're going to discuss how to beat maintenance savings goals with LAKOS Premium Efficiency Separators. Today's agenda will include life of maintenance and operations, common problems with processed water management, traditional processed water management methods, premium efficiency separation, what and how, separation compared to other technologies, and then we'll do a small cost analysis. Process fluid filtration is common in most manufacturing facilities, and it can be anywhere from spray nozzles and spray bars. Filtration is used on pits and remote sumps, as well as tanks with inside the facilities in a lot of cases. Heavily used on process cooling towers and on heat exchangers, both plate and frame as you see there, as well as shell and tube. The goal or number one expectation of any maintenance team at a facility is to deliver consistent product that meets quality standards and quantity requirements on schedule. Typical goals of most maintenance teams in a manufacturing facility include maintain or increase operational efficiency, reduce unscheduled downtime, and to meet budgets. Doing their job successfully requires various strategies, which include but are not limited to, in most cases, forecasting, planning, redundancy, durability, and maintainability. Common problems caused by particles in the water stream or in a processed water stream are process equipment wear, which leads to equipment downtime, product defects, which reduces the product quality, inefficient heat transfer, which increases energy consumption, constant equipment maintenance, which leads to increased labor cost, and then you have the pit, sump, or basin cleaning, which leads to lower production output. Traditional process water filtration methods in most plants include, for the most part, barrier filters. And as we look here, you'll see a variety of different types of barrier filters, from bag filters to basket strainers to cartridge filters. And then you also have barrier filters that are more self-cleaning, which would be including self-cleaning screens, as you can see here. And then you get into sand media tanks. So they're mostly what the maintenance teams will use as filters in a lot of cases in manufacturing facilities when they're looking at barrier filtration. Some of the limitations of barrier filtration include constant maintenance. That's primarily when you get into the bag filters, the basket strainers, or the cartridge filters. As you know, they have to be changed out, which creates a lot of extra labor and maintenance. Then you get into screen filters and sand filters. And some of the issues that come into play with sand filters, for instance, is excessive water loss during a backwash cycle. They have to replace the media, usually annually. And they also both have low thresholds of solids loading, as do bag filters, basket strainers, and cartridge filters. So that's some of the limitations that you'll find with barrier filtration. Then we look at the centrifugal action separators, primarily our EJPX series, which is our high efficiency series of separators, and how they fit into process applications. Some of the advantages to using centrifugal action separators is you can easily remove troublesome particles from processed water. You have consistent flow and pressure downstream, which is very critical, especially for spray nozzles or heat exchangers. And in a lot of cases, separators are used as a pre-filter to limit downstream filter maintenance. And of course, extending out backwashing cycles or flushing cycles when it comes to screens and media tanks. This is just a breakaway of one of our EJPX separators and how it works, and then we'll show you a video. But I want to give you a quick explanation of how the actual separator works. You have the inlet and the outlet, so water enters the top chamber, and separators are a 3-chamber system. So you have your upper chamber, and then you have this center chamber, or what we'll call the separation barrel. That's where all the separation would take place. And then we have a bottom chamber here, which we consider the collection chamber. So that's where all the solids would end up after they are separated. So the water enters this top chamber, and as soon as it enters this top chamber, it's really being drawn to the low pressure point or toward the vortex, because water is always trying to find a path of least resistance. Now, what we've done at LAKOS over the years to make our separators more efficient is added different patented features to gain efficiencies. One of our big added features is what we call our Swirl-X slot system, which is a series of 3/8 inch in width slots in the top chamber. Those slots do twofold. Basically, they increase velocity into the separation barrel, and they also create more of a laminar flow effect in the barrel to make it easier to get the particles to the outside of the chamber. So as water enters that top chamber, it's being drawn through those slots, increases that velocity, creates that laminar flow effect, and as it gets in its downward spiral motion, trying to find a vortex, we use a deflector plate right above the collection chamber. So as soon as water hits that deflector plate, it's redirected, and then it picks up the vortex at that point and just follows the vortex through a vortex finder, out the outlet, and downstream. So the beauty of the LAKOS high efficiency separator is there is no moving parts, there's nothing to replace, it's uninterrupted use, and it's maintenance free. You just have to purge the solids periodically out of the collection chamber. So now Zach is going to start a video that's going to show a little more of detail about what I just explained. So as you can see, with the separator, in reality, LAKOS separators are twofold. Obviously, they're filtration, but they're also big concentrators. So what they're doing is taking the problem out of the processed water and concentrating it to the collection chamber to be able to be purged into an area that makes it easy for the maintenance team to get the particles out of the process and out of the facility. LAKOS Premium Separator Performance. Now, all of our LAKOS separators are third-party tested, which we'll explain here in a minute or two. But these efficiency ratings are not LAKOS doing testing and printing them. They've actually been sent out to a lab to be third-party tested. So right now, with our high efficiency separator on a single pass, we're at 98% efficiency of a 44 micron particle with a 2.6 specific gravity. As you go up in specific gravity, or the particle becomes more dense, really in reality with any type of centrifugal action, it's all about density differentials. The heavier the particle and the denser the particle, the better the separator can do. So the next testing we did was with mill scale, which is about a 5.4 specific gravity, or about 5.4 times the weight of water. And we did that testing at 25 micron. As you can see, we were achieving a 99% efficiency at 25 micron on a single pass with mill scale. And then steel, even being more dense, obviously is still at a very high efficiency. So the larger, it's all about size and density of the particle when you're using centrifugal action. Now there is also a little chart down here that will give you an idea, because a lot of our maintenance partners we deal with will ask about micron levels and how fine is actually a 44 micron particle or a 25 micron particle. This is a nice chart to give them kind of a benchmark. 44 micron of 325 mesh would be your fine silt, for instance, in a river water application. 37 micron or 425 mesh is equal to plant pollen, the real fine plant pollen that flies through the air. 25 micron is the size of a white blood cell. 8 micron is a red blood cell, and 2 micron is bacteria. So as you can see, for a system that uses no barriers, it is very fine filtration with our high efficiency separators. As you can see, we're the only centrifugal action separator company on the market that provides third-party independent testing with our separators. So as I said earlier, when we build the prototype of the unit, we send that prototype out to be third-party tested, and we get a report back from the lab that we have availability for you to show your customers or to provide to the maintenance teams. And this is just a breakaway of an actual, or a picture of an actual EJPX separator, low profile separator. So this third-party testing is available for your maintenance teams to review. Where does LAKOS fit within the applications in a plant? Well, we talked earlier about some of the different things that filtration is used for within the plant. For instance, protecting spray nozzles, we talked about, cleaning up pits, sumps, and basins, heat exchanger protection, and then pre-filtered in bags or cartridges. Now, when it comes to protecting spray nozzles, like I had said earlier, it's very critical that the spray nozzles always get consistent flow and pressure, which the separator is always going to be able to give it to, because the separators require no cartridges or screens to blind off. So you're always going to have consistent flow and pressure to the spray nozzle, which obviously increases overall productivity for the customer. And then you also have the separator, like we said, is a concentrator. So instead of, for instance, sand ending up in their spray nozzles, which could affect the overall quality of the product, the separator concentrates the sand into a 55-gallon drum in this aspect. Or when you're cleaning basins or tanks or sumps, we use a series of what we call hydro boosters or eductors, which are basically little venturi jets that are placed inside the tank to make sure that we are getting the solids to the pump that's going to feed the filter. In this case, our separator. Again, we concentrate all the solids out of the liquid stream and put it into the hopper in this case, and then the clean water discharges out the outlet of the separator and just goes back to this header that feeds these hydro boosters. So in tank cleaning, really what you're doing is you're just basically using your closed loop system and just constantly turning over the tank or basin and removing the solids as the separator sees them. Heat exchanger protection, again, very critical that we have consistent flow and pressure to the heat exchanger. And then, of course, pre-filters to bags or cartridges. So what we're trying to do here is to take the bulk of the heavier part of the problem out and concentrate it into this 55-gallon drum to leave less particle going downstream to the bag housings. That will extend out the life of changeouts on these bag housings, which is critical, especially for labor dollars, or more importantly, in this day and age, acquisition and disposal of existing bags. This is a nice little cutaway of a job that we did with the maintenance team at Caterpillar in East Peoria, Illinois. And it shows about a 5.5 month payback on this application. So basically what this was a heat exchanger application where the heat exchanger was part of a little closed loop heat treating application where they were stamping metal plates and cooling those metal plates, and the water that was being used to cool was ending up in a tank and then being pumped out of the tank through the heat exchanger and back to the spray nozzles. So it's its own little closed loop system. The issue they ran into was they tried to start out by filtering the water with a set of bag housings. And as you can see, we talked about how heavy scale is earlier. When they were trying to lift bags out that were filled with scale, the bags were tearing and ripping and making a mess. So at one point, they just started to bypass the bag housings, which became the next line of defense, the heat exchanger, and that was becoming their filter. So what they were doing basically is paying a service team to come in every 5 weeks to service the heat exchangers, clean them, regasket them at a cost of about $8,000 per cleaning and maintaining. So we did a quick ROI with the customer, and we showed that this was their cost before installing a LAKOS separator. It was running them roughly about $83,000 a year in maintenance and labor cost to clean the heat exchangers. And then they took into consideration the cost of a new LAKOS system to prevent the scale getting to the heat exchanger, which was about $38,400. And that showed a quick payback period of 5.5 months. Now, they have not had to have the heat exchanger service since these systems have went in, but you can see the amount of scale that the separator is taken out and putting into this hopper here. Always want to work with our maintenance teams and try to come up with the best solution for their application. So we want to focus on the solution versus just trying to offer them a product. We also want to make sure that as part of our solution that we're making it easy for them to get the problem out of their facility. As we had said earlier, the separator becomes a concentrator. We'll concentrate the particles to an area to make it easy to get out of the facility. We're also very flexible with our line of separators as far as material makeup. Our standard units are carbon steel, but we also offer 304 stainless, 316 stainless. We can also scotch coat the interior for water chemistry issues. We can offer high temperature and pressure options if needed. And in a lot of cases, we like to pair barrier filters for maximum effectiveness. So this is a nice picture here of a system that we're using the separators, the first line of defense. This was installed by one of our distributors in Florida, Jerry Hartley. And what he did was he was replacing a media tank that was cleaning up source water that was coming in from a canal. One of the issues with the media tanks is a large amount of backwash water and maintenance. So, and it takes up a lot of footprint. So what we did here is we designed a system with Jerry and to show the separator as the first line of defense, and then we put in one of our self-cleaning screens as a polishing filter. So what the separator doesn't get, the real fine suspended solids, ends up being taken care of by the self-cleaning screen. So our job is not just to sell a new separator to the customer, but to sell them the complete solution, as the maintenance teams are always looking for. Just a quick chart here of where the limitations and advantages to each type of filtration that's offered by LAKOS. Our separator is obviously the core product, and you'll see 45 micron or larger, but they will get down as low as 10 micron because it's all still based off that size and density of the particle. It's designed primarily for inorganic particles with a specific gravity of 2.6 or heavier. One big advantage of LAKOS separators is they can handle very heavy solids loading. As you can see here, a standard single separator can handle up to 5,000 ppm or 0.5% of solids. They have a wide range on flow rate as well, anywhere as low as 5 to 10 gallons a minute, as high as 12,700 gallons a minute on a single separator. And they can be manifolded to handle higher flow rates if need be. Self-cleaning screens, which are more polishing filters, have limitations. They can go up as high as 500 micron. They can go as low as 5 micron. They can handle organic and inorganic material. One of the limitations with any type of barrier filter is you have to take into consideration how much of a solid loading situation it can handle. As we said, separators can handle 5,000 ppm, where a polishing filter or self-cleaning screen may be able to handle max of about 100 ppm. They also have a very wide flow range. So that's in a lot of cases, that's why we'll use the separator as a pre-filter to the polishing filter to make sure we're getting a bulk of the heavier particles out of the system before it hits the polishing filter. Then you have your media tanks, which are size for 5 micron or larger. Again, organic and inorganic material. Again, light solid loading, not as light as a self-cleaning screen, but about a 200 ppm threshold. And they are a little different when it comes to the overall flow they can handle. And they do take up a lot of footprint for that amount of flow. Top takeaways: add a LAKOS separator to increase operational efficiency and reduce your maintenance budget. Maintain product quality by reducing equipment wear. And LAKOS has solved customers' fluid filtration problems since 1972. As you can see, here's a variety of different companies we deal with on a regular basis. Down here below, including Nucor, Gerdau, US Steel, Toyota, GM, and many more. And like I said, I want to thank everybody for their time today to jump on this webinar. And if you have any further questions, you can contact either myself at LAKOS, or you can contact your regional manager, which would be Tom Cabzit for the West Coast, and would be Maria Hernandez for Latin America. Thank you.